All right. Problem number two, add two numbers. We're going to try to do this one a little bit cleaner this time. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero, except the number zero itself. Awesome. So, it may seem a little unintuitive at first that these linked lists are backwards, but it's going to make it a lot easier because think about how you do addition. You start with the ones place and you move up to the tens place and so on. So by allowing the head of each list node to be as you iterate through it, you go up in places. That's just how you naturally do addition. So it's actually doing us a favor. But yeah. So what is a linked list? I figured I'd go over this real quick. So, an array in computer science is a collection of items. A linked list is a organization style where rather than having everything in one group and in one bunch stored in the same area, you essentially just have each item have its own value and a pointer to the next. So let's say you were like a teacher and you were bringing your kids out to recess. Would you rather keep like a careful watch on every one of the kids, or would you rather have like a buddy system where each kid just has to know what kid is in front of them in line? Of course, probably not the safest way to do things. Of course, if you're a teacher, I plead with you to make sure you're watching all your kids, but safety does not exist in these analogies and hypotheticals. So we're okay. It's all good. So, yeah, back to the problem. Right? So pretty straightforward. We just have a few considerations that we have to make. So, what do we have to do? I'm going to try to do this a little bit cleaner than the last one, but sometimes clean code is harder to think out loud because sometimes it just makes too much sense. All right. So, what do we need to do? Well, we need to return a final linked list. So we're going to return a summation list node. Specifically, the head list node. That's important. So we're going to need to hold on to the first list node because as we add up, hold on to the result, we're going to go through each digit of the list, of the resulting list. But as we iterate through, we start to, well, it's easy to forget about the head node. So we got to hold on to that so that we can return it. We have to iterate through the digits and get total. Let's see, what else? We have to consider when each list ends because we don't want to be trying to add numbers that don't exist. And also, we had to consider how L1 might end before L2. If you're adding 5 and 500, you might iterate through both of them at the same time, but L1 will end before L2 does. All right. Yeah. All right. Cool. One other consideration we have to make is the carries. So we have to consider when we're adding up each digit that the result might mean that we have to change the result of the next one. It's intuitive when you're doing it by hand. Code, it means that you had to basically pass on a piece of data to the next iteration of the operation that you're performing, which can be a little tricky at times. Okay, first, let's take what we're going to return because we're just going to be editing this and then returning it at the end. So let's say result equals list node. All right. Now, it's important that we consider what this means. When we say result equals list node, we are establishing what we're going to return at the end, but we do have to be careful because when we it already has some inherent values as defined up here. So right now, the current value is 0 on the first one, and that's not exactly what we want. But you know what? I think I'll run it later on to show the problem that arises. Um, that doesn't make a lot of sense. Will it ever make sense? You never know. But yeah, so I always love doing this style of programming where you set up the start and then the end, and then you got to figure out the middle. So we know we have a result, and we know we're going to return that, but what do we do in between? Okay, well, we're going to have to iterate through every digit in the summation, in the product, well, in the final product. So we need to have a pointer to each digit. This is important. We want two different variables here. We have the result, and we have current. Result is almost going to be like a constant because we need to go back to the head of it. And it's not two directional. It's one directional. You can go forward in the linked list. You can't go backwards. So it's important that you always maintain the first um, thing. Well, the head node. If it was like a doubly linked list, meaning that on top of in each list node including .next, they would also include something like .last. Then you could just iterate backwards. But even then, all right. So we have current equals result. Let's see. We also have to consider the carries. So how do we make a variable called carry and assign it to 0? And this will factor into each iteration, each addition of every digit, because we can assign carry to be like 1, and then that value will hold on, and then the next time that we add two numbers, we can add the carry as well. But more about that later. So we have while. Okay, actually, yeah. So let's see. So we want to iterate through the two, the two lists, the two numbers. We want to stop when both lists end. Um, so how do we do that? You can't do it like you would a normal for loop because it requires that you reassign yeah, it's not a list, it's just like, it's one item at a time and each item points to the next one. So there are some funky ways that you could do that, but let's just do it like this. We're going to say while L1 or L2. And then we're going to say if L1 dot next, well, sorry, or if L1 equals L1 dot next. And then the same thing for L2. This is good. So again, same thing. We have the start and we have the end. Now we just need to figure out how to add up the digits in between. But this way we'll iterate through the list one item at a time, while also making sure that we're not iterating through numbers that don't exist. So we have while L1 or L2. That means that we start at the start of both lists. And then at the end of each iteration, we say, okay, if L1, which means that if that is a linked node that exists, and if it is a linked node that exists, then it will have a dot next. Let's say that L1 is just one digit, it's just like the number 1. Then at the start, we'll have while L1 and L1 will exist. It will be a linked node with the value 1. But then at the end, say if L1 equals L1 next. That means that L1 will be assigned to L1.next, and so L1 doesn't have, like a brother, and it's going to be reassigned to the value none. So now L1 is none, as we can see up here, it's inherently none. Now that L1 is none, when we go back up to the top, L1 will return false, because none returns false. The absence of a value is false in Python, at least, in most programming languages. Okay, awesome. So now we have how we're going to iterate through the list. So now we have to add up each digit. Well, the numbers one digit at a time. So first, let's get the first value. Now, why don't we just say L1 plus L1.val plus L2.val? That's because we don't know whether or not L1 has a val or L2 has a val. Those two could be none. So what we're going to do instead is store them in a variable that can process the case that it doesn't exist. So we're going to say val1 equals L1 dot val if there is L1. So it's like a one line assignment. Otherwise, it's just zero. This way, we can just do the addition carelessly because, you can always tack on a plus zero in addition and it doesn't matter. This way, we're making sure that, let's say that L1 has only one digit, but L2 has 10, that as we try to add up L1 and L2, that we don't get in trouble as we're trying to add numbers that don't exist. Rather, we just replace all numbers that don't exist with a zero. Zeros are harmless. Awesome. And then total equals val1 plus val2. Awesome. All right, so here's where it gets a little tricky. We're going to say current.next equals list node total. Now, why current.next? Why not current? Well, that's this one's gonna be hard to describe. Good challenge for me. The tricky thing is that we're trying to offset the fact that we're starting with a result. Current already has like an inherent value, and the problem is that it just is a little bit cleaner to make a new list node that you assign a value to upon creation rather than making a list node and then changing its value. Because then when you return it, you don't have to like make sure that you're not adding in a value that shouldn't be there just because that was the inherent value that it has. Because remember, when you make a list node, it starts with a value of zero. So that's why we're only playing with the dot next. Because that way making sure that the inherent value of each list node does not become a factor because we're assigning each list node value right away. Awesome. And then we're going to iterate through current as well. Cool. I think I explained that all right. All right. So this is looking good, isn't it? Why don't we run it and see what happens? That's not right at all. That's not right at all. So there's a few things. First of all, it starts with a zero. And that's because we return result, and then we assign the dot next value of result over and over again. But the problem is that when we initially made the head node, it inherently has a zero. So by returning result, we get zero, and then the rest of the actual result. I'm sick. I have a lot of brain fog. return result next. Okay. So that got rid of that problem. Now it's a little bit closer. The problem that's left over. 10. And a 10 is too damn big for one decimal place. We have to carry the 1. This 1 needs to go over to the 7 to turn it into an 8. See by what's expected. Now we just had to add on the carries. So let's say, so we have carry equals 0. How about we can say carry, after we do the addition, we could say carry equals total. And we're going to do floor division. That's a quick way of saying if it's greater than 10, the tens digit, if that makes sense. So, for example, if we have 14 divided by, well, floor division by 10, that's just going to return 1. Because 10 fits into 14 one time, and it just doesn't worry about remainder or anything. So that's a quick way that we can do that. Now, let's add that on in the next loop to the addition. So we get the carry, we add it on to the next one. We're getting there. Now here's the thing. There's a little situation we have to consider. Let's say that we have something like 9 plus 9. Well, we could iterate, based on this, you would iterate through it once. Go through 9 and 9, you'd assign each value to the next one, which would be none, and then would be none, so it's, well, none or none, so it'd be false. So you wouldn't even go through it. What happens? We have to carry that 1 to a digits place that doesn't exist yet. So, thankfully, we can just say or carry. So now, if carry, even if L1 and L2 don't exist, we can add on carry. Carry will say, hey, hold, wait, don't forget, you got to carry this final 1. So, let's see. Now it should cover more test cases. So we got 1 right. We're getting there. Oh, that's one of those edge cases. Oh, okay. So you can see we did carry the 1, but we didn't get rid of the 1. So we just kind of duplicated the 1. How do we get rid of that? Well, where is each value being assigned? It's being assigned right here when we make the new list node and assign the total value. So if we use floor division to get the 1, how do we get to get the tens digit? How do we get the ones digit? Perfect place for modulo. Modulo, if you don't know, is like getting the remainder division. So you're saying divided by 10 and then just tell me what the remainder is. So 14 modulo 10 is 4. Really useful. So that should work on more, but I think we have one more edge case to worry about. All right. So it did. It did work on the 3 test conditions, but I think we have one more thing to worry about. Actually, do we? We could submit. I think we might not cover everything. Oh, it worked. You know what? I really thought I had something to worry about. You know, the boss music running. Okay, so not good on memory, but beats most people on runtime. So that's a pretty good solution. Um, yeah. So to go through that one last time, we make our head node and we hold on to that. We iterate through that with a pointer. We hold on to a carry value so that we can add one. It will never be more than one, but we can add one to the next digit place. We iterate through by reassigning each list node to its next value. And we also tack on the carry value in case we have to expand, in case, it's like 5 plus 5, and it's two one digits, and then you get a two digit number. All right. We grab each value and make sure that it exists. We add it up with the carry. We get the carry for the next value if it exists. And then we just assign the next value in that node. Yeah. And then finally we return dot next because we don't want that leading zero. Yeah. All right. So it was a little finicky, but we got there. Thanks for joining. Yeah. Yeah, more to come.